So the last factor that I wanted to talk about affecting the solubility equilibria is that of the complex ion formation. So like I said at the beginning of the video, a complex ion is an ion containing a central metal cation, the metal cation, generic metal M, right? Metal cation bound to multiple molecules. Now metals can do all sorts of crazy configurations. They can do tetrahedral, they can do octahedral, trigonal bipyramidal. They have plenty, because of their d orbitals, they have a lot of opportunity for bonding, okay? So the complex ion formation is actually a very common phenomenon when we are dealing with some sort of metal cation in solution, okay? So let's take the example that we started with at the beginning of the video of AgCl, okay? AgCl, we already said it will dissociate, right, in water to Ag plus Cl minus, and this is in equilibrium here. The Ag plus and Cl minus, right? So once those two ions go into solution, if you add something into this solution that will interact with the Ag plus, then you could have a potential for the formation of a complex ion. So for instance, let's add to this aqueous AgCl solution, let's add some NH3, okay? Let's add a little bit of ammonia. So this ammonia will actually undergo, the silver will interact with this ammonia to form AgNH3 2. You need 2 over here with a plus, right? So this whole species is going to be an ion, okay? And this particular equilibrium here, this particular equilibrium actually has a Kf, which is a formation constant, a Kf of 1.5 times 10 to the positive 7, okay? Times 10 to the positive 7. And remember, when we have a really big equilibrium constant, there is a large tendency for that equilibrium to favor the products, right? We haven't dealt with that in a while. We're really favoring this product here. That is to say, a lot of this equilibrium will be shifting towards the silver ammonia complex ion, okay? And this formation constant is just the tendency for a metal ion to form that particular complex ion. And these are a little different, differently written in the sense that they have the ions on the, or excuse me, yes, an ion or the dissociated species on the reactant side, and then the full complex ion on the product side, right? So you're pushing the whole equilibrium is going towards this way with this very large formation constant. Now you could imagine that because we formed this large, this complex ion here, this equilibrium down here has taken it from that original equilibrium that we started with. That is to say that the second equilibrium that I have on here is taking the Ag plus from the first equilibrium. And just like we were talking about with the last examples, if you decrease the concentration of the product, you drive the overall equilibrium towards those products, okay? So if you decrease the concentration there, you drive the concentration towards the products. Thus, you increase the solubility of the AgCl ion. Increase solubility. So these three factors are the main points that I want you to know, 4 factors that can affect the solubility equilibria. And I also want you to go read in your book, like I said, section 17.5 in your book, to get a little bit more information on this. And then be sure to ask me any questions if you have them.